This podcast deals with visualization in R. It is a slightly longer podcast with lots of examples. Here we see the content. The page numbers correspond to the script for the R course. So we will start with general graphic parameters. We will look at how to arrange plots or different plots in one window. Then we will look at the classical scatter plots. We will be adding some arrows and further elements to plots. We will see the classical box plot, the strip chart, pie chart, dot chart, bar chart and histogram. And we will have a small excursion into 3D point cloud plotting and then a small outlook into animations. We have a small appendix where we have a color chart and some information about very typical error messages. There is a warning at first. The principle "ask your lecturer to get a precise answer" doesn't work in this chapter. You have to develop your own precise ideas and use Google and our help to implement those ideas, because every single visualization is as unique as its creator's idea. The topics covered in class, they will only cover basic concepts, and you will ideally learn from this podcast and from the course how to deal with open questions of visualizations, and you will be able to help yourself finding out what you do not yet know. So this podcast is not especially about how and what, but it's about how to find out. But of course we also need to lay some technical foundations. General graphics parameters exemplified with the curve command. With R we can very easily plot a parabola. The code is displayed here, so you say that you define a function f of x equal to x squared, and then you can just type curve of f, take care that you use the right brackets, and then what R provides you with is either this picture, or maybe it will even be a cut-off picture that just shows this side. This is the default setting. Now before you continue watching the podcast, please make sure that you have R started on your desktop and that you have the script for these slides available. You should have downloaded that from Moodle. It's reasonable that you try to execute the commands at the same time on your desktop. So, plotting a parabola may be fine, but what you would like to know is several more things. So, in order of appearance, we define the function. And now instead of just saying curve of f, we can specify the limit of the x-axis with xlim and the limit of the y-axis with ylim. These are both vectors indicating the start point and the end point. Then you can choose a line type. Here we have chosen the line type 3. This is numerically coded. You can check in the internet about a list what kind of codes correspond to what kind of graphics. We will also show a short list then here. You can describe the line width. That makes the line width more wide. 4 is quite a large line. The standard is 1. Then you can specify the color. This is again numerically coded. Just try yourself what kind of colors you get when you change that. Then you can of course also put labels to the axis. That is the command xlab or ylab for label. Then you can just specify a character, a string actually, a string of characters in hyphenation marks, what these labels should be. And all that, observe very well, is included in the one single curve command, and the round bracket just closes after here. Now, after you have plotted, you can still add a title with the command title. This is now a new command, and you open round brackets and specify a string, again in hyphenation. A small remark here, with the command \n, you make a new line here. These are the basic parameters. Again, it's reasonable that you let your script run in the background and that you try to maybe change 2 or 3 of these parameters. Now you can also plot more than just one function, one parabola. For that you will need to indicate what kind of functions you have. That happens here. On top you have the parabola, you have a square root and a x to the 5 function. You would like to plot them all in the same window. For that you use the curve command for the first one. You can specify line width, line type and color, and you should leave the ylab empty, because otherwise you may risk to overplot the labels there. Then you just go to the next line, say curve of f2, and now it's very important that you put the statement add equal to true, because that means the curve will be added to the already existing plot. And the same you can do with the third curve. Usually you should be able to distinguish those curves from each other here by giving them different colors. If you want to add a legend, which is very reasonable in such a plot, use the command legend. The first 2 values are the position of the upper left corner in xy coordinates in the corresponding plot. Then you have to provide the caption of the legend. You have to provide the line types that you were using for plotting, and you have to provide the colors you were using for plotting, and you can specify a line width. Make sure that the parameters are in accordance to the parameters you have been using for the plotting of the curve, otherwise your legend becomes a little confusing. So ideally you have already executed your script while having a look at this podcast. Now maybe take a short break and play around with some of the plotting parameters you've just discovered. Go into R, use the script provided and see what happens. The next small topic is the axis parameters. So it can be very useful to adjust axis parameters, be it concerning the axis range or be it concerning the axis labels. You can do that manually. What you have to do first is use the command axis equal to false in the curve command. So that happens down here. You specify the ranges and everything and you plot your curve, but you do not want to see axis. The next step, you can specify adjustments using the axis command. This is shown here. So axis, you have to specify which side corresponds to the orange numbers here. You have to specify the so-called ticks, like at what x labels or at what x values you would like to have the labels, and then you specify the labels here, for example, some months. You can do the same with the next axis, specify where you want what labels. And then you have the third axis, specify at what positions you want to have what labels. The point about this is here in this graphic, if you would put all the months on the x-axis, you would have to enlarge your graphic, otherwise you would see interlaps between the months or the namings of the months on the x labels, and that would not look that nice. In the end, you can connect the axis with the command box that happens down here. So ideally, again, go to the R script and check yourself what the signal steps are doing here. Now, what can also be quite useful in plots is you can put arrows. Arrows are specified by several parameters, most important ones being the starting point x0, y0, then you have the ending point x1, y1, so this indicates from where to where the arrow goes. Then you can specify the length of the arrow section, so it's not the length of the whole arrow but just the length of that very part here at the tip. You can also define the angle, here 30 degrees, that describes the angular aperture of the arrow, and the code, the last one here, can be used to say either you want to have the head on the end, you want to have the head on tip, or you want to have an arrow with head on both sides. There can also be some different parameters, that's why I have the dots here, like you could say what kind of color, line width, can even specify line type, and so on. These are the very same parameters as we have already seen at the discussion of the curve command. Arrows. You can also include text directly into a plot, which can be a tremendously useful feature. You can specify at which position, x and y, you want what text. Don't forget the hyphens, since it's a string. You can specify color. You can specify the size of the character with the cex command. So you just type cex equal to some number, and then you scale this text in accordance to the general text scaling of your plot. So cex could be 1.5. That means your text is 1.5 times bigger than the standard font used in this plot. So this can be useful to identify curves directly by writing on them. One could also turn text around. We will see that a little later. Then you can add a grid to your plot. This is a little bit of a rigid command. It's very easy, but it doesn't allow you to change very much. So the command is just grid, and it makes those grid lines. It plots them actually at all the x ticks and at all the y ticks, and that's it. You cannot really specify more in this command. Again, the same game. Ideally you have already worked through the R script. Now it's time to play with some parameters, maybe shift some arrows around, change some aperture openings, and work out what those parameters actually mean. Now, this chapter is maybe a little artificial, but it's important to have seen that R offers the possibility. It's about plot arrangements. Often you would like to have two plots in the very same picture, and there are two ways of going for that. The first way, which we will discuss here, is the command layout. The second is the command parameter, mfrow equal to some number. Please use Google to find out what this command is doing. We will be using it later in the course as well. So the command layout. To start with, you should clear all graphical parameters set so far. This is done with the command def.off. This is highly recommended. The layout matrix or the layout function needs a matrix specifying how many plots you would like to have on which line. And that is basically it. So you need to provide a matrix. You will see a more complex example right now, or just differently put example. So here we have a layout matrix that is just the other way around. The layout matrix is seen here. So now we have 1, 2 instead of 2, 1, giving plots that are horizontally arranged instead of vertically. In this plot we see something else that can be very useful, and this is the command parameter OMA, outer margin, and with that you can specify borders of your plot area. You specify 4 values corresponding to side 1, side 2, side 3 and side 4, and you specify the corresponding margins or the distance towards the end of the window. If you would like to put a title on the full picture here, you can use the command mtext. Copy this syntax. Outer equal to true means that you really plot outside the active plotting window. That means you would really plot up here and not here or here. And you can again specify the size of the characters. So this was a little fast, I know, but the only way of learning this is by doing and applying it. We can excessively exaggerate here. We can try to make a very complex arrangement of plots. So what's interesting here, you can actually also arrange plots in a way that you do not always have the same number of plots per line. Like here you have 2, one big one, a small one, then you have 2 that are equal in size. Here you have just 1, here you have just 1, so this is also possible. Of course, what becomes more complex is your matrix. Generally, you have to tell R how many fields you would like to have per line. So this is 4 fields. That's why we have 4 columns. 3 fields, right? It's not 4, it's 3. We have 4 lines and 3 columns, and we just order the matrix. So here the first entries, they tell us, well, this is just one plot and it takes the whole length. Then we have 2 plots, 2, 2 and 3. The first plot takes 2/3, the third one 1/3. Then we have 4, 5, 5, that's the other way around, and we have 6, 6, 6. You can specify the width of the single field, so you have 3 fields, and the first field is a little larger than the second fields. That is seen that it's 2, 1, 1. And the heights can also be specified, the heights of the single lines. The second line is higher than the others, that is very clearly distinguishable here. Now if you execute this code in your own command, in your own script, make sure that you make the graphic window a little bit larger with your mouse, otherwise you will get an error message because all that thing would not fit in. A word of advice, be careful with these plotting arrangements. Make sure that you really don't overdo it here. I think at this point it's important to talk about the workflow of visualization. So these are basically 4 steps. The first step is you should develop a visualization idea without any use of computer programs. So just think about what you have, what you would like to show. Then question and challenge the visualization idea for sensibility. Is it reasonable? Excuse me, the word should be reasonable here, right? Reasonable. Especially in view of the audience you're expecting. And also in view of your audience, you should check whether your visualization idea is easy to understand, because visualizations that are good are always easy. Not all easy visualizations are good, but the other way around, it's definitely true. And then only in the last step you sit at your computer and then you check how practicable is this idea in R or maybe also in Excel, whatever program you would like to use. And if, of course, you will have troubles or maybe it's not standard or you will not find anything in a script, the next step is to ask Google how you implement your idea. Okay, now would be time to again do some exercises. If you're interested in these plot arrangements, it's now time to practice. Let's proceed to more classical and again more useful plotting techniques. So chapter 6.3 is about scatter plots. Before we start with that, let us introduce a data creation function. This function is just for your convenience. I would not want you to spend time to read in data files all the time because I would like to focus on visualization right now. So you are provided with a function called test data, and this function creates a data frame. You do not yet have to understand how it does that, but you have to know that it just does create a data frame with 5 variables, an index, some kind of value, the value size, the value gender, and some age. When you execute this function and save it under a variable name data, then you get the data frame and you can plot it. Be careful, it will not always look the same because I use some random numbers, so you will observe different results than maybe what you see in the slides. Make sure that you execute the whole function, so mark everything and then press Ctrl R. You have to do that every time anew when you restart R and want to use this function. Okay, now if we want to just have a look at this data frame, it can be very useful to just use the simple command plot and then you give the variable name of your data frame, plot data. What you then get is a scatter plot, a first overview. All the variables are plotted against each other. Of course, this is not tremendously useful if you have factors here like gender, then you just get female and male or the other way around. So this is not necessarily something extremely useful, but for the numerical variables here, it can give you a first overview of what to expect from your data frame. The classical scatter plot now is a restriction to 2 variables, like for example 2 metric values here, data any value and data size. So the scatter plot just uses a 2-dimensional coordinate system and plots all the available points in your data. You can by default use just the command plot, or you can extend this command by parameters we have already discussed. There is one new parameter, or 2 actually. There is PCH for the symbol type, point, I don't know what it means actually, but it's for the symbol type, and you can define the option type equal to P, that means P stands for points. There are other options there, we will see an overview soon. This is already the overview. So we have the parameters for point or line plots. So there is the type, which is important here. Then we have the PCH, this is, as I said, the kind of symbol. It's here. And you have a whole chart describing what kind of number corresponds to what symbol. Observe that you can also have some filled symbols. These are the symbols here, 21 to 25. You can specify a fill color with the command BG. So just type PCH, for example, equal to 21, and BG equal to 2, then you have a symbol here that is filled with red. The other symbols are not fillable. Then you have the command line type, as we have already seen. There are several numbers corresponding to several types. I would advise you to check that on Google. You have the line width, also discussed already. You can go to 100 or beyond. And you have the color, which is either a number or a name. So you could theoretically say col equal to red. Don't forget the hyphens. Usually you will just abbreviate that by numbers, or more advanced you will use the RGB color chart, which we will see in the appendix to this chapter. Here are again the line type parameters, so you can read yourself what they mean. The most important ones are actually the parameter P for points, then the parameter L for lines, and then you would also have a parameter type equal to B, which plots both lines and points. There is also different stuff, like here for example the type N. This plots x and y coordinates and doesn't plot anything yet. This can be useful when you start plotting things on top of each other. We will come to that. Especially now it's time to get a little bit of experience about different colors, about different symbol types. So please go to the R script and change some of these parameters and observe what is happening. If we proceed one step further, in scatterplots we can actually include some more information. So we can try to identify some factor levels. Let's say here we would like to see the size and that any value quantity as a scatter plot, but we would like to be able to distinguish between male and female as well as between 3 age groups. Now we can code the male-female by color red and blue, and we can code the age group by symbol type. So this can be done here. You say plot data any value and data size, and then you can say color is equal to red and blue, and if you use the straight brackets of the factor gender, then you will assign colors to the different factor levels, but only 2 colors of course. And the same you can do with the PCH, with the symbol time. This is 3 different possibilities, and the factor is called data $H. So this will already create the different coloring and the different symbol types. Of course you should not forget to put a legend, first for the colors and then also for the age groups. Make sure that you do not confuse the reader by using some characters with the genders already, because that's just color coded, and don't use colors when you describe age groups, because that's just symbol type coded in this case. There is a little word of caution. If you do all that, please check the order of the factor levels to be sure that they are properly shown. Typically R chooses the factor levels in alphabetical order, so make sure that your colors really correspond what you think they should correspond to. All right, so this plot may not be extremely well organized, because there is a lot of information and it's not especially accessible. So be careful with this kind of plot. Maybe you find better ways of visualizing this data. Now, how can we add some further elements to our plots? There are several elements we can add. One of the elements that is very important is straight lines. There are approximately 4 versions of doing that. The first is you can specify with AB line, line specified through the regular equation for a straight line. This is a plus b times x, so a is the intercept, b is the slope. Then you can define horizontal lines by just indicating h equal to some number. You can do the same with vertical lines, and now, very interestingly, you can also do that with regression lines, as we've already seen. If you have a regression object, let's say you have done some linear modeling, then you can directly plot that regression line into your scatter plot. What is very important if you want to do this is that you start with the command plot. X and Y, first the x-axis, then the y-axis. You have to start with plot because AB line doesn't open a new graphic window. Only when you have this thing open, and you have to make sure to keep it open, you can start using AB line in all the possible versions. Again, you have a lot of parameters for this AB line. Basically, they are the same as we've already seen in the curve command. Of course, it's not only straight lines that can be interesting. You can generally define lines by the command lines of x and y, where now x is a set of coordinate points and y is another set of coordinates, for example like this here. And now the command lines, it just specifies the single points that lie on the line. So we start at point 1, 1. That's here, right? Then the next point is at 2, 0. The next at 3, 2. And the last one at 4, 0. So with this we specify straight lines between points. Again, the same graphic parameters then afterwards as in the command curve. If you would like to add a general curve to your plot, then you can use the command curve. So first you open a plot window with the command plot xy, and then you define your function and you just plot it with the command curve, and don't forget to set add equal to true. Please see chapter 6.1 for more details on that. Can also be interesting to do the other thing, that you start actually with a curve and then you would like to add some points to it. So that's just a different way around, the other way around than before. For that you use the command points and you just specify x and y coordinates of your points, as well as symbol type, color, line width, and so on. So this is a useful command, points. Just make sure again that you have a graphic window open such that you can actually plot some of those points. Now of course it gets a little more funny when we combine several curves and maybe several points in one plot. Now we can also do that with the command par of new equal to true. So we do not necessarily have to use the curve commands and then add equal to true. We can also just overplot the things with this command. So we start with defining some two functions and some x and y coordinates of points. Then we just start plotting the first curve in a specified window. If we would like to add points, we could now use the command points, but we can also do it with this command par of new equal to true, and then just say plot xy and come up with all the specifications we want. This will include the points into the curve plot. And now we can even say we would like to plot an additional curve on top of that. Again, we could use the command add equal to true, but this time we do it with par of new equal to true, and we just provide the curve command to be plotted. Be cautious, you should avoid overlapping axes by always specifying axis equal to false at the beginning, otherwise you risk an overplot. It's usually recommendable to specify the axis manually, as we have been discussing before with the command axis. You should also not override captions, because some of the plotting commands, they by default use different captions for the axis, so make sure that you put empty hyphenation marks for the X and Y lab. If you want to specify them, you can still do that in the very last plot there. Now it is time for a slightly longer exercise. We have artificial data as introduced with this function test data, slide 132. Please visualize the variable size and separate between sex and age. Then think about which color and symbols to use for which factor and create a well-explaining legend. Next step, please add lines to the scatter plot showing the means plus minus 1 standard deviation. Separate again between the sexes and make sure that one understands what means what. Then please think about other visualizations of the observed data, maybe without using R. You can also ask Google about that. Just think what could be reasonable. There are several options here, I would say. This exercise will also be explained in class, so you do not necessarily have to do it now if you are lacking the time. If you would like to, then please press the pause button now, because I will provide you with the solution right away. So let's look at the solution. So the solution to this exercise, the first thing we need to do is we need to activate the test data function. Let's do that and actually create our test data. So I just execute all of that, and then I see I got a data frame that has the structure as already described. Now if I want to do some plotting, maybe I already have done some plotting before, so it can be useful to execute the command def.auth. Now since I haven't done any plotting before, it cannot be closed, so that's fine. Now the first thing is we just plot the variable we are interested in, and this is this size variable. Then we can think about some x-axis limits, some y-axis limits. Maybe in the first one you left that away because you just wanted to have a look at your data. So let's do that maybe in the first round, data $size, have a first look. So that's what it looks, right? That's not so bad. Alright, you will be adding some legend somewhere, so maybe it's reasonable to put some more space here on the x-axis, and maybe also some more space on the y-axis. That's actually why we have increased the range there. Now we can actually just execute what I have written here. And then we see what these specifications lead to in my case. Maybe your case looks a little different because we are using random numbers. Alright, so now you have to make sure that you're using the right colors for the right data type. So for that you would have to check that really red corresponds to female and green to male. This is the case because F is alphabetically prior to M, so the red corresponds to the female and the green is the male. The symbol types 1, 2, 3 correspond to the factor data $H. Let's have a look shortly. So that's young, middle and old. So alphabetically speaking, middle will be first, then you will have old, and then you will have young. So here you have to be very careful when you assign the legend afterwards. So let's look at the legend. First the color legend for male and female, that's easily done. Also logical concerning the appearance. Now here you have to be careful with the associations of young, middle and old. Since again I said the alphabetical order is such that the first one appearing is middle, the second one appearing is old, and the third one appearing is young alphabetically. So you have to order it 3, 1, 2 concerning symbol types in order to be matching with the legend. So let's have a look. And then you see this is a gray legend. Observe here the parameter bty equal to n. That means I don't want to have any box around the legend. That's my choice here. So far with the legends. Now let's add some lines to this plot. As described, we wanted to have the mean split according to gender. Right? So we use the command tapply as discussed in chapter 5. Then we get an object m. Let's have a look what m actually is. So this is a set of 2 values, namely 2 means for female and male. We need the same thing with the standard deviation, we call it s. If we would like to access the first element of this thing, of this tapply object, we use double straight brackets. So this is how to access a list of elements. If you, for example, check with the command str what m is, then you see this is some kind of list. Of course, you can also see what happens if you just use one straight bracket, then you get the female as well, and that's you don't want, so you really just want to have the value, and for that you use the double straight brackets. Good. Now you can plot these lines. You can just say AB line, and you want to have a horizontal line of the females at color 2, which is red. You would like to have a horizontal line at female mean plus female standard deviation, and the same with minus, and maybe you would like to see different line types, so that's what happens here. The same is done for the main, exactly the same. So here you see the same stuff for the male mean and the male standard deviations around the mean. Of course, this is not really an optimal visualization. You can make it at least a little better by maybe putting an arrow somewhere. Now let's see where that arrow is now. You see the arrow now, the red one, just created. You can also put some text under that arrow saying that this is the mean of female, and you can continue like that. Okay, so maybe this exercise is good for training with the data and with visualizations, but maybe it's not a good conceptual exercise, because I think this data shouldn't be visualized like that. Better visualizations may be with box plots. We will come to that very soon. But maybe at this point it's time to make a break and to finish this first part of the podcast and continue with the rest of the visualizations in a next podcast.